Hi everyone, today we're going to be doing vertex form of quadratics. So we've already talked about what standard form is of a quadratic function. And today is about vertex form. One thing, you will need to have like your pencil, you need like a red writing utensil, like a red pen, and a blue pen as well for me today. So we have our little glue in here that talks about what the vertex form looks like. So this is the vertex form. Y equals either a positive or minus a, parenthesis, x minus h, parenthesis squared plus k. So what we're gonna do first is we're gonna talk about what each of those attributes mean there, and then kind of dive into graphing it. So first one, the plus or the minus. That tells you if you have an x-axis reflection. Okay, so that happens if the a is less than 0. So if a is negative, right, that means it reflects over the x-axis. If a is positive, that means there's no reflection. The a is your vertical stretch or shrink. So it is a vertical stretch. If a is greater than 0, so if a is a number bigger than 1, or bigger, that's supposed to be bigger than 1. So if a is greater than 1, so if it's 1, 1.5, 1.6, anything like that, it is going to be a stretch. And it is a vertical shrink. If a is less than 1, so if it's a fraction like 2/3, 1/4, etc. The h value that's in the parentheses, that is actually your horizontal shift, so moving left or right. So if it looks like this, x minus h squared, you're actually moving to the right h units. And if it is x plus h squared, you're moving to the left h units. So it's kind of like the opposite of what you would think there. And finally, this k, the plus k is right at the end. This is your vertical shift, so you're up or down. If it is a plus k, you're going to go up k units. If it is minus k, you're going to go down k units. So that's kind of what you can get from the vertex. Why we like this? Because then when you see this, you actually are going to have your vertex right away there, which will make it very nice. All right, so real quick, we're going to talk about what the anatomy of a parabola looks like and then actually go into graphing. So here's like a plain old parabola. We have the vertex right here. And you notice it is symmetric, so on each side, whatever you do to one side, it's going to be the exact same on the other side. And here's what the anatomy is, actually. If I were to go over 1 unit, I would be going up 1 unit. If I go over 2 units, I'm actually going to go up 4, because this is, we were doing y equals x squared. So if you do 2 squared, that goes up 4. If you go up 3 units, or go over 3 units, you're actually going to be going up 9 units. All right, so that's how kind of the problem works. You go over 1, up 1. You go over 2, up 4. You go over 3, up 9. Now how this can be changed, if you have an a value, you multiply that 1 or 4 or 9 by an a value. So for example, if up here we see that we have a vertical stretch of 2, we'd go over 1, instead of going up 1, we'd go up 1 times 2, which would just be, we go up 2. Instead of going over 2 and up 4, we go over 2 and up 8, because we're going to be doubling that, and so on and so forth. So what we're going to do here is we're going to be graphing 3 different, All right, we're going to be graphing 3 different parabolas or quadratics on this thing. So we're going to do our first graph with your pencil. We're going to graph y equals x squared. So your typical old parabola. With this, all right, we have our vertex at 0, 0. Okay. Usually, I always write my little like anatomy to the side of this. So I usually go over 1, up 1, over 2, up 2. Oh, sorry, up 4. Over 3, up 9. All right, if you notice here, a value, the a value is just 1, so we don't have to change that 1, 4, or 9 at all. So what we're going to do is we're going to start our vertex, and we're going to go over 1, up 1 to get our next point. I'm gonna go over 2, up 4 to get my next point. And I could keep going on, but I usually just need 5. What if you have on one side, you can just copy that to the left side. And here is my y equals x squared parabola. All right, now what we're gonna do with your red pen, all right, we're going to be graphing y equals 2x squared. I'm gonna write this down here actually so I have a little bit more room. So if I graph my little anatomy right here, go over 1, up 1, over 2, up 4, over 3, up 9. We now have an a value. Our a value here is 2, so we're going to have to take all of these terms and multiply it by that a value. So instead of going up 1, we're going to go up 2, we're going to go up 8, and we're going to go up 18. So now the vertex is still the same because we don't see any shifts there. Starting at 0, 0, we're going to go over 1 and up 2. We're going to go over 2 and up 8. And unfortunately, I didn't plan this out very well. So I'm going to erase this stuff real quick. I'm going to go over 2 and then go up 1, 2, 3, 4, 5, 6, 7, 8. So now here is my y equals x squared, or 2x squared parabola. So it's a little bit more narrow. So you see with that stretch of 2, all right, it makes it more narrow, a little bit more condensed. Okay, now what it is with your blue pen, we're gonna graph this function. This function is y equals -1/2, parenthesis, x plus 4 squared plus 1. So this is what it is in vertex form. So if you notice, typically we start at 0, 0, but now we have some shifts here. So the first shift happens here, x plus 4. That tells us that we are actually going to go left 4. And this plus 1 tells us that we're going to go up 1. So I'm going to start my probably here. I'm going to go left 4, 1, 2, 3, 4, and down or up 1. So there's my first point there. What I'm going to do is I'm find all the other points. If you notice over here on this, I've got a negative. So that means instead of facing upward like the last two did, it's going to be reflected over the x-axis and be looking downward. And we have a 1/2, all right? So we're going to kind of shrink it a little bit. So what I'm going to do is I'm going to make my little, over here, 1 and 1, 2 and 4, 3 and 9. And all right, we are changing these 1, 4, and 9s here. I'm multiplying them both by, multiplied by all of them by -1/2. So this becomes -1/2. This becomes -2. This becomes -4.5. So we do that from all of this. So when it says negative, you're just going to go down instead of going up. So I'm going to go over 1, down 1/2. Over 2, down 2. So my parabola is going to look something like that. So look, it's not as like narrow, it's a little bit like extended. All right, so that's how you would graph it in vertex form. Now we're also going to do a problem where we're going to write the equation of a quadratic. So we're going to write an equation of a quadratic. We're going to write it in both vertex form and standard form here. It tells us that we have a vertex of -2, -5, and tells us that it has to go through the point f of 4 equals 22. So what I do first is I'm going to put it into vertex form as much as I can. So this would be y equals, I don't know what my stretch is, so I'm going to say just a. I have -2, so I'd be going to the left 2, so x plus 2 squared. And -5 means that I went down 5, so -5. Now we have that, but we need to figure out what that a value is. So what we're going to do is we're going to plug in 422, okay, into our equation. And solve for a. All right, so I'm gonna plug that in. So the y is 22 equals a. My x is 4 plus 2 squared minus 5. And we're gonna do some math here. I'm gonna add that 5 over. So I get 27 equals a. 4 plus 2 is 6 squared. So this would become 27 equals 36a. Divide both sides by 36, so I have 27 over 36 equals a. I'm going to reduce that fraction. When I reduce that, I get 3/4 equals a. So now that I have a, I'm going to replace it into our original equation right up here. So this would now become y equals 3/4 parenthesis x plus 2 squared minus 5. What we can do here is we can actually multiply this out. To write it in standard form. So here's how I do that. If I see that, that little squared means we actually multiply it by itself twice. So what I'm gonna do is I'm gonna write it out twice. What I'm gonna do first is I'm gonna take care of that x plus 2 times x plus 2. So that would become, if I FOIL that out, x squared plus 4x plus 4. I'm going to distribute that 3/4 through to all those terms. So I have 3/4 x squared plus 3x plus 3 minus 5. Combining like terms I see, and that would be y equals 3/4 x squared plus 3x minus 2.